Welcome to Static Electricity Lab. I have electroscope. It was invented by Abraham Bennett from England in the year 1787. Why do I have electroscope? I have electroscope to demonstrate the static electricity. And what is static electricity? Static electricity is imbalance of electric charge on a surface of an insulator. Then I do need an insulator. Well, I have a CVC pipe. This is insulator. What makes it insulator? This is not a conductor. That means the electron cannot move freely on this pipe. That means if somehow you can transfer some electron on this pipe, these electrons won't be able to move freely because insulator do not allow electron move freely. That means there would not be any flow of electrons. That means electron will be sitting and electron would be at rest. So you can accumulate electrons on an insulator like a CVC pipe. The CVC pipe from neutrally charged to become negatively charged. How can you do that? Well, we're going to use a process called charge by friction. What is charge by friction? Well, it's a fancy way of saying I'm going to rub this CVC pipe with my hair. Well, I have something better than the hair. I have the animal fur. I'm going to rub this CVC pipe with animal fur, allowing the electron to transfer this CVC pipe, and that electron will be accumulated and going to be resting on this CVC pipe. Of course, we're not going to see it. That's why we have this electroscope. If we bring this to the electroscope, and this leaf will repel. Currently, this electroscope is neutrally charged, so is the CVS pipe. Let's draw that. This is neutrally charged, and this is the electroscope, which is also neutrally charged. I'm going to allow all the electron, or as many electrons as possible, to transfer it to the CVC pipe of the insulator. Now I'm going to draw this right now. Now CVC pipe become negatively charged is because so many electrons move from animal fur to the CVC pipe. Now I'm going to bring it. Let's call this scenario 1. Let's call this scenario 2. Let's call this scenario 3. I'm going to bring this to the electroscope. And let's see what happens. If I bring this close to electroscope, and let's see what happens. Again, I'm not going to touch it. So this is a metal ball, and this is a metal leaf. That means this is conductor. That means electron can move freely. That means flow of electron possible. When I bring the negatively charged CVC pipe over here, that will push all the electrons on the metal ball to as far as possible, and that is to the metal leaf. That means there would be redistribution of charges. That means this metal leaf will become a negatively charged, and this will become positively charged. Negative repel, so they will repel by friction. Now I'm going to bring it close. I did not touch it, so this is called the charge by induction. So let's see what is happening. So this is called charge by induction. So this is negatively charged, so that all positive gonna remain over here and all negative gonna come over here as far as possible, so they repel each other. So that's why they're gonna repel each other, so the leaf go away from each other. Okay, now scenario 4. If you remove the rod, what happened? It's gonna go back to where it was before. Okay, so this is called charge by induction.
Free Science Lab to fall in love with math and science, especially programming.